Right, in this video, we're going to look at the empirical rule. So can you download this file here? Okay, so with the empirical rule, if we've got a distribution and this distribution is roughly bell-shaped, so it looks like a normal distribution. So let's say we measure the heights of a set of students, and we put it into histogram, and that histogram looks like a bell, right? So we're quite confident it's sort of symmetrical, and it's major values are around the mean. Most of the values are sort of centered around the average. Right, well, then we can apply the empirical rule. So let's just say we measure our class and the average height in the class, let's say it's 165. Yeah, so average height of students, 165, and the standard deviation is, let's say it's 5 centimeters, something like that. So what does this tell us? Well, it tells us that roughly, if you move one standard deviation away from the mean, okay, so it's, the 165 minus 1, so that's where you get the 160, and the 165 plus 1. We know that about 2/3 of students are between 160 and 170, right? What's more, we know is if we move 2 standard deviations away from the mean, so remember the mean, 165, so minus 2 times 5, 10, right? We know that 95% of students are going to be between 155 and 175, right? If we're going to move 3 standard deviations, just to quickly show you how I'm doing this. So 3 standard deviations, that's 165 minus 3 times 5. Right, and how I get the bigger value? Well, it's 165 plus 3 times 5. Right, so we know that 99.7, so almost all the students are going to be between 150 and 180. Right, so we need to know that this distribution is roughly normal. So if we had a histogram and it looked like a bell, right, well then we can go ahead and we can apply this. If we don't know the shape of the distribution, if we don't know if it is normal, well then we can apply Chebyshev's rule. Hope that helped. See you in the next video.